Thank you. Uh, Thank you for showing up. I think it's almost the end of the day, and I'm really happy to see all the energy. And yeah, this is going to be an interesting talk about AI and machine learning, and we are talking about deep learning. So we'll try to understand what they are, but in terms of geospatial aspects. So here, I would like to set up the context that we're not going to talk about AI particularly. We're talking about AI in geospatial content, or what we call is Geo AI. So today's corporate leaders crave information that strengthen their operations and guide the strategic decisions. So leaders definitely they go ahead and take the um, uh, initiatives, the the strategic intent, that's what we call, and then the decision is rely on those strength and the operations and the guidelines. So in recent years, that quest has changed in ways, in a large way or small way. For one, information has never been so abundant, right? And its ability to help executives see around the corners has never been so profound. So credit technological phenomena such as the Internet of Things, IoT, that's what we call, and artificial intelligence, AI, for this particular shift. So they are producing information of nearly incalculable breadth and depth. In fact, some researchers say that the world has created as much as data in last couple of years. So it has all the prior years of its existence. So it's more than the data has been generated in last couple of years with the power of AI and IoT. So just wanted to know about how many of you are working with AI technology at this moment. Oh, all right. So we would like to go on very basic. What is AI? And we try to understand what is machine learning and deep learning, and what's the relation between them in very layman term. Okay. So artificial intelligence is now all over the place, but it has got mainly three categories. We start with the artificial intelligence, or AI, is a paradigm computing to get machines to be as smart as us, like human, right? And machine learning is a subfield of AI. It's about learning from the data, derive rules, and detect patterns. It's about giving computers the ability to learn without being explicitly programmed. You're generating some sample or trained data, and machines is learning from that without explicitly programmed. And deep learning is specific machine learning technique using deep neural networks, which is really good with high dimensional data like voice, images, videos, and especially the real time data. That's why the IoT part is coming into place. Now, the field of artificial intelligence has made rapid progress in recent years, matching in some of the cases, even suppressing human accuracy at tasks such as computer vision. And I'm sure if you have heard about the natural language processing, NLP, and the machine translation. So the intersection of artificial intelligence and GIS is creating massive opportunities that weren't that were not possible before, right? So AI and machine learning and deep learning are helping us to make a better world by helping increase crop yield through the precision of, for example, agriculture, to the fighting crime by deploying predictive policing models we can generate, to, to predicting whether the next big storm will hit for the disaster recovery and being better equipped to handle it. So it's actually providing the information at advance so that you can take better decisions and optimize the resources and plan for it to deploy on the ground. Now let's take a look about how ArcGIS and AI capabilities help you today. So the question arises here, do we have AI capabilities? Do we have deep learning capabilities? The answer is yes. ArcGIS has got the artificial intelligence, machine learning, and deep learning capabilities. It is there for past couple of decades, I would say. Uh, we have a lot of tools, geoprocessing tools. I'm sure if you have worked with the imagery, you know those supervised classification, unsupervised classification. Those are the algorithm that we used to derive before, but we never used to call them as deep learning or machine learning. So let's take a look how can ArcGIS and AI capabilities help you today? Generally in three categories. The first one is the object detection. So it's detecting object from imagery. If you have raster data, you can derive some rules there. In ArcGIS Pro, you can export some sample data, training data, and you can um, ask the system to learn from its exported sample data, and you can change detection from the imagery, land cover information as well, and especially here I would like to say on the videos, video analytics, you can bring together the CCTV feed. I'll show you one example in later part of my presentation. So video feed can become in real time from CCTV, and you can ingest that information in our what you call in the ArcGIS engine is ArcGIS Enterprise, and we can identify different objects from there. The next one is a prediction. So you can predict like water pipe breaks when it's going to happen based on your previous data, your asthma rates, your diseases or crimes based on some crashes, like your transport authorities might be interested in here, and then fires, congestion, everything. So how it can predict is, if you have a archive data for the past incidents, it can identify the predictions where the next event is going to happen. And the next one is a pattern detection, is about clustering. So if it's about identifying the hotspot location of a disease or cluster and many more. Let me give you a quick example. There are a lot of accidents in a particular place in a geographic area, and they want to identify what are the places they have more accidents prone area, and they want to do something out of it. So let's say they have millions of records. It's very hard to get, make sense of that particular data. So by running the clustering tool, we can actually identify those intersection where most of the time the accidents are happening, and can identify those places to take some action so that we can mitigate that particular risk. As I said, we do have machine learning tools available in ArcGIS today, and we can integrate deep learning and machine learning engines as well, which means not only within ArcGIS, but we can integrate with other external frameworks to be work with our S3 platform, such as different machine learning libraries. I mean, I'm sure if you have heard about TensorFlow or scikit-learning, PyTorch. Generally, we use ArcGIS API for Python to integrate with those external frameworks, IBM Watson as well. So as in the three areas, ArcGIS has the machine learning tools. Number one is prediction. I'll give you some example on that. And then we have clustering and classification. Classification is mainly those imagery and raster. So classification, it's impervious surfaces to help effectively prepare for storm or flood events based on the latest high resolution imagery you can identify from it. Then the predictions, you can predict impacts of climate change on the local temperature using global climate model data. So it's about global data. You are integrating in ArcGIS, train your system to identify or depict the local environment, how it's going to uh, play a role here. So there are a lot of machine learning tools, from classification to clustering to prediction. ArcGIS has a series of tools that already have machine learning in their algorithm. So in the prediction, we have empirical Bayesian kriging. I'm sure if you have heard about those tools, and these tools are not new. These tools were there. Maybe we didn't notice. Maybe you have worked with them but never, uh, tell them as a machine learning tool. Forest-based prediction is a new one in ArcGIS Pro, and there are some other deep learning tools has been introduced in recent Pro. This morning I show about Pro 2.4 capabilities. So deep learning tools like export sample data for the deep learning, and then you can change the detection also using deep learning. Clustering, like spatially constrained multivariate clustering, density-based clustering. So these are the clustering tools, and the clustering tools has got different algorithm like DB scan, HDB scan, this kind of algorithm you can apply. And definitely hotspot is one of the common key that we use. And then the classification, maximum likelihood classification, random trees, support vector machines as well. So in the prediction, let's take this use case, predicting asthma hospitalizations per block group in Connecticut, and exploring the top factors behind the prediction. So it in ArcGIS we generally run a forest-based classification tool and the regression model, a geographically weighted regression like ordinary least square regression. These tools, if you run that and bring them together, the data, so we can identify, predict. The next is the clustering. Use give nearly about 50,000 reports in a traffic between 5 p.m. to 6 p.m. in a particular day in LA, and where the traffic zone that can be used to elicit the feedback from the current drivers in that area. So we try to solve some problems out of it. And 50,000 records, when you plot on the map, it's really very hard to make some sense out of it. So in this case, we are running some tool at the back using multivariate clustering tool and then density-based clustering tool as well. Then do the image segmentation, hotspot analysis, and cluster or outlier analysis. And also you can do this on over the space and time. Classification, this is mostly on the imagery, high resolution imagery. We do with the maximum likelihood classification and random trees. These are the tools are available in ArcGIS Pro. So you can classify impervious surfaces to help effectively prepare for storm and flood events based on the latest high resolution imagery, right? Now you can make predictions like where are the places at a particular place where the road crashes, water main failures, like our utility folks might be interested, traffic injection congestion where the traffic is heavy traffic when office is closed and people are going to get back to home. Then the crimes and law enforcement, definitely you can make some predictions where the next, some riot or something is going to happen. You can predict depending on the previous data and deploy your resources or make sure that your resources are available to be deployed properly. Then estimated arrival time. This is, in real time example, you take Grab example. Grab tells about if I take from here to my home, how long will it take from here to drive to my home? That's the estimated arrival time that actually predicts based on all the consumer data at the back, right? So these are the different predictions that you can do. These are the few of the statistically significant grouping of in your data, pattern mining or clustering examples, right? Previously, I was talking about two algorithm. Definitely, we use in clustering what is called as a DB scan and HDB scan. So you can run those tools to identify some of the hotspot in the data. Now, machine learning tools integration with external frameworks. So ArcGIS is not within the machine learning tools are available here, but also we can integrate with external frameworks such as AWS or Azure AI, TensorFlow, IBM Watson, scikit-learning, and so on and so forth. So we generally use on our side ArcGIS API for Python, or sometimes we call ArcPy. We use both of them to integrate here. So next I'm going to run with AI and real-time information. So real-time is definitely here I'm taking one example of how real-time object detection by type, and this is detecting the cars and the trucks and the buses, and I'm analyzing this in a operations dashboard, right? So the transport authorities, they can extract a lot of street cameras by using AI. So the live CCTV feed can be ingested into the system, make sense out of that particular CCTV footage, identify what are the different objects, so real-time traffic patterns you can identify from here, the congestion analysis, adaptive signal control, incident analysis, and anomaly detection. Just few of the examples that you do. So this is a dashboard application that lets you monitor your CCTV feeds and detect objects of interest like cars, bus, trucks, motorcycle, even the pedestrian. If you notice on the left hand corner, the app categorize each detected object and display those categorized as level in the camera, and you can see what is the percentage of accuracy as well. That this is a car, like okay, sure, 90% maybe. Uh, so that's how the machine learning works, right? The app also tracks and display other information and statistics such as vehicle count, total number of vehicle. So that's you can see on the right hand side the dashboard. It's counting how many traffics are there. With this app, you can also gain greater real-time awareness of the current traffic conditions. You can spot the congestion as it forms, detect violations and other safety issues, and adaptively adjust signal controls to improve the traffic flow. So you can take some action to make it more better. Now, this is another dashboard that aggregates the detected observations from all feeds across the area you want to observe. So you can see the patterns of each location here. You can use an embedded map to zoom in to a specific location, then select a camera feed, and then within the dashboard. So you can also define the custom alarms and that generate the alert. So you can generate the alert system as well. You can define something that can send you the alert, maybe an email or a particular SMS. Maybe, for example, when more than 20 trucks pass through an intersection within a 5 minute period. So then you want to alarm somebody so that he takes some action, or your police or your people on the ground. Here is one more dashboard. This is a static dashboard. So this dashboard application lets you play back previously detected traffic events so that you can view and analyze your historical traffic patterns. So you can see that in the dashboard, car trends above normal is 7 for 65 observed locations, something like that. You can also detect statistically significant traffic anomalies by comparing the average historical traffic volume to the current real-time volume. So when the traffic conditions meet certain thresholds, like an abnormally large number of pedestrian crossing at a single intersection, let's say there's a football match in the stadium and it ends, and suddenly everybody is going and they're trying to cross over a particular location, a particular crossing intersection. You can trigger alerts and notify your staff. So how it works at the back technically, you see CCTV feed is coming, and then it's you can detect the different objects. So it's decoding the feeds to frame using the OpenCV or definitely the available API, and those API you can using the deep learning model here. A trained deep learning model detects objects or incidents. Then what you do is, here multiple products are at the back. We are using a real-time product called for S3 is called Geoevent processor. So in the Geoevent server, you can also name it. So it can ingest into the system using Geoevent server, and then you can store that data for future analysis. This morning I spoke about real-time analytics as well as geoanalytics, which means your big data analytics. And then I can visualize that data and the information in real time in my dashboard, as you see in my video. And then later on, historical analysis, anomaly detection. This is, you need to find, analyze the patterns back in time with replay capability, spot the anomalies, leverage the geoanalytics for faster processing. So those who do not know what geoanalytics is, when the information, the real-time data coming into the system from different sensors, maybe there is like 10,000 feeds per second sometimes, for example. And you can imagine like hourly, and then 6 hour or 12 hour and 24 hours. In one day, millions of records and information are coming into the system. It's heavy. So on that time, what we do is, in front of Geoevent server, technically we put a system called Kafka. I mean, I'm sure many of you are aware. So we just distribute the loads here, and then we are storing those real-time data model into a big data store. What we call is a spatial temporal data store. We are storing that data for doing that last number 5 historical analysis here. So that's the power of geoanalytics. That's using the power of distributed computing and storage. So it's like a parallel processing. It does in-memory processing of your data. That's why it is much more faster. You can process millions of records in maybe 60 millions of records. What you tested is you can get results in 3.5 hours, which if you want to do that in pro, I mean, sure, the machine will die, right? So that's the power of geo. So when the geo event comes in real time, geoanalytics comes as well, because you definitely do not want to destroy your data. You want to store them for your predictions. You want to predict something out of your historical data, your archive data. So this is generally how it works, and technically it's all happening with the ArcGIS Enterprise with real-time capabilities. You see the sensors, everything is coming to the system. So Geoevent Server is actually a functional role. It's bringing the real-time GIS to the ArcGIS Enterprise, and this product has got few capabilities such as ingesting high volume of and high velocity of data from connected devices, sensors, a large Internet of Things landscape. All the sensors available in the market. You just need to get the API, the right um, connector to connect to that and get the feed from it. Provide streaming analytics that the data while in transit to both and refine the data and then identify the patterns of the interest on the fly. So if you think you do not want to store the data for future analysis, you can also portray the data on the fly and do on the fly analysis, real time capability. For example, I want to see all the real time traffic of the airplane at this moment, and imagine you do not want to store that for a moment. So you can fly, you can on the fly you can visualize those information in a map or in a dashboard on any devices. So this is more or less the architecture. The feed is coming to the sensor, to the ArcGIS Geoevent server, and then there is a spatial temporal big data store. It's storing that information for your future prediction analysis. There are a lot of tools available in Pro, and then you can visualize the information from desktop, your apps, and it's available for API. You can extend it through REST API for other system to integrate. Right. All right. So I'm sure you have seen Notebook Server this morning. Actually, those who are here are missing a parallel session running on hosted Python notebook. So I thought like maybe I can just show up in my slide. So in this morning, my colleague Sharon show you Notebook Server that is part of ArcGIS Enterprise, and it enables hosted Python notebooks. It's powerful because it's not only allow us to integrate with distributed services, data, and ArcGIS analytics with all the open science libraries. So we are able to build Python scripts and share them with other organization or within your different departments with ArcGIS Enterprise. So the integrated notebook interface also allow you to browse data from your organization or maybe some other sources like online or Living Atlas, and Python snippets for selected data and analysis tools can also be automatically added to the notebook to accelerate how you build your workflow. So why I bring this slide is actually you do the data science work, you do the AI, artificial intelligence work, and you can see the notebook server is actually bringing whole the Python libraries. I think it is coming with 470 plus Python libraries is getting installed when you are actually configuring this particular system technically, and it's integrating with different third-party open science libraries. For example, Conda, then scikit-learning, as I mentioned earlier, right? PyTorch, TensorFlow is my favorite, and then you're storing that information. So in Notebook Server is a intuitive, it's a interface. It's like Jupyter Notebook in your ArcGIS Enterprise. Now the next slide, I'm going to show you a CCTV feed. And if you notice here, um, it's actually you are driving the car and you are detecting the cracks, right? And it can identify three different types of cracks here. Once I complete that particular analysis, um, then I prepare this dashboard that lets you aggregate and view the road damage data collected by the road cracks detection model. So there is a model running at the back. Now the app includes a map that lets you visualize the areas where cracks are most prevalent, as well as the widget that display the summary of the statistics. So maintenance workers can use this dashboard to understand, patterns and the trends related to the road damage in the areas they serve. So with this understanding, they can better plan and prioritize their work activities, helping you more efficiently maintaining aging and damaging infrastructure. So you can take um, uh, some action out of it. All right. Uh, okay, Cheryl is showing up. It's time's up, but I would like to show you few of the deep learning tools that are available in Arcgis Pro, so that you can go and test it yourself, or you can drop me email, and I would be happy to work with you. Any of the POC that you are trying to build, I want to be part of that, and we can work together to build that prototype using machine learning, artificial intelligence, and then real-time analytics. So I wanted to show you this demo in ArcGIS Pro. This is ArcGIS Pro is a great application for connecting your GIS infrastructure and doing complex analysis. So the release of Pro 2.4, which has been released a couple of weeks back, that brings you the tool so that you can help your data to make better decisions. So I want to show you some of the deep learning capabilities in Pro 2.4. This is nothing to do with the real time, but there are the deep learning tools that are available. So let's take a look at the what you call is a BLM land. So this is a particular workflow that I'm trying to do to identify the sometimes well pad in the oil and gas industry. Sometimes they have permits, sometimes they don't have permits. So I'm trying to identify the illegal permits here. Okay, so that's the problem statement. Let's try to do that. So let's do this bookmark closely, go to that one, and look at the BLM land in southeastern New Mexico. So these are the well point hubs. So BLM means Bureau of Land Management. Okay, and the rapid growth of oil and gas development in this area is a rich area. As you can see, there are a lot of wells. Now the BLM might want to monitor the progress of new drilling on their land, as well as look for potential illegal drilling. So those are the well pad. They do not have um, permits. Okay. So I'm going to monitor this. Let's bring the new Sentinel imagery. So at a 10-meter resolution, when I turn off the wells, we can clearly see the well pads across the landscape. This is very high resolution imagery. Now Sentinel-2 is a great change detection since it is refreshed every 5 days. When I compare the old imagery and the new imagery, I can detect there are 3 well pads have been completed. So let's try to do the detection. Can go to this place, click on the appearance tool. You just take a look that which are the tools I'm using here, and there's a tool called swipe tool. And once I do that, just take a look in the middle of the map. You see 3 new wells here, right? Right? Do you see that change? Just look at the middle of the map here, this particular part. So I'll turn the well points provided by the state, and we see the interesting problem. We have at least pads, well pads that look like they have been built with no permits. These two. So how can we find more of those across larger landscapes? So this is a particular small area. So what are going to do? We are going to find on the larger area, like whole area. This is very small point, right? So now we need to create training samples, right? Like these. So deep learning model can learn how to find the well paths. So I'm going to the map and click on the explore, and let's go to this well path training. So these are the training sample data. Let me zoom in. So you can see these are the training sample data. Now Pro 2.4 allows you to export these samples to an external deep learning framework. In this case, TensorFlow we are using. So I already configured the TensorFlow before. Give me just 1 minute, then I'll be done. Yeah. So I would like to show you the geoprocessing model. The tool that I was talking about is called um, export training data for deep learning and detect objects using deep learning. So these tools, these are the deep learning tools which are available in Arcgis Pro 2.4. You can take advantage of that. And nonetheless, I would like to show you the result. And do you see that those blue points, the blue color rectangles, these are the wells, they do not have the permits actually. So you can run the whole workflow from an imagery, and you can identify using deep learning to, which are the well paths do not have permits. So this is a quick example. I could have explained more, but looks like no time. Okay. Please drop me an email to me or our support team as well if you want to work with any of the machine learning and AI, especially with integrated IoT. I'll be happy to work with you on any of the POC. So this is it from my side. I hope you like it. Thank you so much.